Yeah.
We're good? Okay.
All right, now I'm in the clear to start. My name is Jonas Helseth from the Bellona Foundation, environmental NGO active in Europe, in Russia, in the United States, we have our headquarters in Norway, and that's also partially why we are here in the Nordic Pavilion today. I'm happy to welcome you all to this event, which is about what we can call a just transition for industry, how to avoid something that I think there's an increasing concern about around in the world, not only in Europe, about the growing perception that there's a contradiction between the economy, jobs on the one hand, industry on the one hand, and climate ambition on the other hand. I was at an event this morning organized by the international trade unions, where we heard also the same kind of signals. I heard similar signals from trade unions in Europe talking about how they fear that climate ambition might threaten jobs in industries like steel, cement, other places. So we have three speakers today. One is Trude Sundset from Gassnova. I'll let you introduce the concept here later, but we also have Hans-Jørg Weddinger from ThyssenKrupp, from the German steel company, and then we have Keith Wiersky, my colleague. But today, first, we're going to talk a bit about technologies. We're going to talk about technologies that can help mitigate that risk that we have, that contradiction between jobs and climate change. And we have a very interesting development in Norway this year. Projects in CO2 capture and storage in various industries, and on that I'm just going to introduce Trude. Please, if you want to come and give a presentation about those plans in Norway. Please.
Thank you very much. Thank you for the invitation to talk about this very important topic. In Norway, we have worked for a long time with CO2 capture and storage, mainly in the oil and gas business. Because we have the oil business and we have done a lot to reduce emissions offshore of Norway. But we feel now is the time to step up the effort and to deploy CCS at a much larger scale than we have seen in the past. And what has changed is actually the Paris Agreement. I think that something very important changed the way people look at CCS, and the reason being that when you look at the targets set by the Paris Agreement, it's impossible to reach those targets without making use of CO2 capture and storage. So it's no longer a question about whether you do renewables or you do CO2 capture and storage. You simply have to do both. And also scenarios that the UN have looked at, it tells you that if you do not do CO2 capture and storage, it will be more than twice as costly as without doing it. But the point is you have to start doing it, because if you are able to deploy it at a large rate, we have no time to lose. Actually, time is already up. So we have to move this forward. And that is what Norway is set out to do. So in Norway, we have done a lot of work already, and we are stepping up the effort. So Gassnova is a state enterprise set up to succeed with CO2 capture and storage. It has existed for almost 10 years, and our deliverables are to manage the state's CCS interests. We work on research through a research program called CLIMIT, and we also operate the CO2 Technology Center at Mongstad, and we work with full-scale CCS implementation. Why do we do this? It's actually three things at the same time. Often I draw my organization map as a triangle, because I believe you have to do all of this at the same time. You have to do research, you have to demonstrate new technology at a high enough scale so you can commercialize the technology, and you definitely have to do full-scale implementation of CCS. And the effort we do from the Norwegian side is quite significant. So the Climate program, which has existed for more than 10 years, has an annual budget of 25 million euros. And we have supported more than 300 projects in the whole of the CCS value chain, on CO2 capture, on transportation, and on storage. And in addition, we've spent quite some effort looking into environmental issues connected with CCS. We have to continue the research because I feel sometimes people think that just by building full-scale plants of CO2 capture and storage, then automatically the next plant will be much cheaper. But that is of course not the case. Once you build a full scale, you have to look at what you've done, and then you need to investigate how can we make it cheaper? What kind of technology development can you do to get the costs down? So you have to feed that information back into research, and then you have to do demonstration as well. And all of this is interlinked and mutually dependent on one another. So we cannot just do either or here. We have to do all of those at the same time, and we're just at the beginning. And then we have this technology center at Mongstad, which is quite unique in its size and in its flexibility. So this is where a lot of companies come and test their technologies. We have been operating it for 4 years and are now planning 3 more years. It's Statoil and Shell and Norwegian State that operates this. And it's quite unique, as I said, because it's open to new technology suppliers that want to come to test their technology. You do find other test facilities around the world, but the size of this is quite big, and also that it's open to anyone who wants to come and test. Gassnova is also the advisor to the Ministry of Petroleum and Energy on these issues, and as I've just described, we have the role to contribute to technology development. But what is even maybe more important is that we have as our mandate to do knowledge sharing. Because Norway has very high ambitions on CCS, but we don't have enough emission sources to actually build thousands of these plants. So what we're planning to do and what our ambition is to show the world, demonstrate that you can do CCS at a large scale, and then we'll share this knowledge with the rest of the world and hopefully inspire other countries to follow Norway. And what we have focused a lot on recently is full-scale implementation with industrial emissions. In the past, we focused a lot on power production and CO2 capture and storage from that. But we saw it was quite expensive, and also what is important about industrial emissions is that you cannot just replace these emissions with renewables, because the CO2 in these processes are created chemically within the process. So there's no way you can avoid those emissions. So this does not compete at all with renewables. And maybe that is a good place to start. Also, some of these capture technologies are cheaper because it's more concentrated CO2. So we believe that this is an important starting point for us. You do see some facilities in other parts of the world, for instance in the US and Canada, where you have a commercial drive to use CO2 for enhanced oil recovery. But in Europe, we haven't seen any projects. There were high ambitions in Europe earlier on, but that's failed, and we haven't seen any projects apart from those offshore of Norway at the Sleipner and the Snøhvit field. And because of this Snøhvit and Sleipner field, Norway has experience with geological storage of CO2, which is a very important part of the CCS value chain. Now back to these industrial emitters. What we're looking at currently is the Norcem cement plant, and we also look at the Yara ammonia plant, and we also look at the Klemetsrud waste to energy plant. So these are 3 completely different industries with different technologies, but they're all global, interesting emitters. So for instance, the cement industry, they emit totally around 5% of all of CO2 emissions worldwide. So if we succeed with this, of course, we will show the world that you can use this technology for cement factories. Now, why are these companies interested in doing that? Because the title of this seminar is how to save jobs and save the climate at the same time. And what's interesting here is because the state is pushing the industry to deliver on what they have promised with the Paris Agreement, the industry look themselves at how can they reduce emissions. And the response from a combined Norwegian industry is that they have to do widespread CCS. And so they have come up with this answer themselves, and they really want to do this. And their approach is that if they can do this early on with the support of the state, they are prepared for a future where it will cost much more to emit CO2. It's not expensive enough today to emit CO2, but in the future it has to be, if you believe in the Paris Agreement, and we need to fulfill that requirement that we have decided on. So these industries, they think that they will do this and create a future where they actually create value for their own industries. We have looked at this, and then we have looked at CO2 transportation using ships. Gassco in Norway has studied that. And then the solution is to have an intermediate storage onshore, and then we will build a pipeline and store the CO2 in the underground. And Statoil have worked on this for us. We have done a feasibility, and we're now continuing into the concept phase. And we have been very fortunate to get funding from the government to continue with all three of them. And we want to do this by 2022. So we do believe the time is now. We look at CO2 emissions from various industries. We think that there's a lot of potential for learnings and for further deployment based on this project. Statoil has shown that there's a large storage capacity at the Smeaheia aquifer. And this project we're planning will only utilize less than 1%. So we think that Norway and the North Sea can be a storage hub for all of Europe, which is quite important for other countries that maybe have struggled in how to get rid of the CO2. The industry believe that they have to do this in order to stay competitive. So this is the only way they can save their industry. And in addition, of course, it's necessary in order to achieve the climate goals. But again, this is what the Paris Agreement is about: push from the politicians and support from the government, and then the response comes from the industry on how to do this technology. Thank you very much.
Thank you very much, Trude, for coming here to present this. I think this is it's very encouraging. As I said, this is an event also about industry, about jobs. And I think that it's very interesting that all of the three projects you're talking about here are in industries that provide jobs and are important for the economy. Now, I have a pleasure to introduce the next speaker, Dr. Hans-Jørn Weddinge, who is the group coordinator at German steel group ThyssenKrupp for climate and environment. Please come and give us some of the industry perspective.
Okay, thanks a lot. Thanks a lot for the introduction. Let me clarify one thing. ThyssenKrupp is not just steel. 30% of our business is steel, 70% is something else. And that something else might be quite important, because that something else, in order to just follow from the very excellent presentation we have heard a minute ago, for example, building cement plants. So we are conflicted with our customers asking us, okay, what can we do in the future? Because cement is very easy. In cement you have two kinds of CO2 emissions. The one comes from heating up your material. There you can use renewables. It's not as easy because you need very high temperatures. The other one is from the carbon embedded in your actual input material. This you cannot avoid, so you will have always CO2 emissions. And that I think is very, very important. I mean, I'm an engineer by training, but sometimes what we need is more linguists. Because yes, we speak about decarbonization. That's a goal. The problem isn't carbon. I mean, look at myself. My doctor rightfully says me, you should lose a few kilograms. One way to lose 10% is if I would decarbonize myself. 10% of the human body is carbon. Interestingly enough, my doctor doesn't like that idea because he says you wouldn't function anymore afterwards. And that is true for a lot of parts of industry. We need carbon and we will need carbon. And as a consequence, it's not about decarbonization, but about that, what decarbonization stands for, which is avoidance of man-made greenhouse gas emissions. Because using carbon doesn't mean any impact on the climate. Producing CO2 doesn't mean any impact on the climate. But releasing CO2 into the atmosphere, there the problem starts. For that, certainly, in many of our industries, these like steel, we are in there operational, these like cement, these like fertilizers, these like chemicals, where we are the plant manufacturer, we certainly are asking the question, what can we do? And to make it also very clear, we are not talking about the CO2 or greenhouse gas emissions of the world as it is today. We are talking, as I was rightfully said, about residual that's left over if we look at other things where it doesn't really make sense much more to use fossil carbon for. What we are looking at, and bear with me that I might actually deviate from CCS for quite a while now, but don't worry, I will get back to that in time, I hope. What we are looking at the moment in the steel industry is to combine the steel industry with the chemical industry. Reason being, the chemical industry needs carbon. So why should it be not the carbon that's embedded in the CO2 that the steel industry is producing? Actually, and I'm not going to go into too much technical details, I'm very happy to answer questions on that one later, but of course, if I were to do it now, it would keep us all night. Interesting enough, an off-gas from the steel industry is not just pure CO2. It is CO, CO2, nitrogen, a lot of other things. So that's a gas which in itself already is very close to what the chemical industry uses as feed gases anyhow, but for some energy issues. So that's the reason why here it makes a lot of sense not to store it, but to do something with it, to do CCU. And that is what we see in many industries could be a very valuable thing to do. So the question now seems to be, okay, if I'm talking about CCU, does that room for CCS, or the other way around, if you talk about CCS, would that kill CCU? No. In industry, we are used to work in value chains. Actually, if we are very true to ourselves, it's not chains, it's networks. It's value networks, and it's about interacting modules. I mean, as you have rightfully mentioned, we're looking at the Paris Agreement. We're looking at one goal, but we're looking at several tools to achieve that goal. One of them is really getting fossil fuels out of energy production, use renewables. Another building block might be CCS, another one is CCU, and so on and so forth. It's very important to understand what we need is a toolkit. We need a toolbox of different tools. There are a lot of things you can very nicely do with a hammer, but not everything. So you need the fitting tool for what you have as a problem. And just to give you a quick insight why, for example, when we do our carbon to chem project, as it's called, which is one of the biggest research projects ongoing in Germany at the moment, what we do in a nutshell is we take the carbon out of the off-gases from the steel industry and embed it in the product of the chemical industry. Certainly, for that means no emission at that point, but that product at the end of its lifetime needs to go somewhere. And normally it goes in an incineration plant. So the question now is what you do, and there you have many options. You can do CCU yet again, you can have it connected to a CCS plant, and so on and so forth, but over time you will not be allowed to have it actually being blown in the atmosphere again. So therefore, CCU, CCS, it's not a contradiction in terms, it's not an either-or decision, it's very much about how can we complement things together, because at the end it's about how can we be sure there's no emission that comes out of it in the end. Even more so, we might be running into a situation where we realize we need to have a negative balance for some things. As I mentioned, there are areas where carbon is indispensable. As a consequence, we might have areas where actually emissions are indispensable for locations, for processes, diffuse things, whatever. So as a consequence, we might realize we need to have storage of CO2, loosely speaking, take it out of the air and bring it underground again. So even if we're not speaking about industrial sources, we might well have a reason to do CCS in the future. And that certainly is very important because what we are talking about is the future 2050 is actually starting to happen today. What we're looking about in terms of investments, equipment, whatever, you don't do that overnight. It takes a decade for that to get on the ground. Maybe more if you have to convince your society that's a good thing to do. And why do we want to do that? Just to follow on that note of, okay, yes, there's industry, but there are also jobs. The good thing about an industrial job in most countries, it's a very well-paid job. I mean, we very often make the mistake, I would personally say, of combining number of jobs lost in so-called brown industries against number of jobs gained in green industries and say, yes, it's equal. Have you ever looked at the wage bill somebody gets in a service industry compared to an industrial job? It's slightly different, so we have to be very careful what we're doing. And let me just finish on that idea of brown and green industries, which certainly a little bit comes into that discussion as well. The green future you have painted so nicely, what does it mean? For a lot of people it means nice green hills and this majestic green tree there. That's about the future we want, green future. And if you look at that tree, all we know is it's better than the grass because the green leaves are closer to the sun. Interestingly enough, if you look even closer, what's the reason? The reason is a brown trunk in the middle. So it's not about green or brown, it's about how do we combine green and brown to one system that really works, is functionable, and can withhold the one or the other storm if necessary, also maintaining its employees at that one. So let me end on that note, if I may.
That wasn't me. Thank you very much for that, Hans-Jørgen. It's a pleasure to have you here, and I think this reminds me of something that I've been thinking about sometimes in this context, about in working in Brussels for now almost 10 years in the context of environment and climate change. And you say this about industrial jobs being paid more and being the kind of building stone of our welfare, and I think that's something that you can also see very strongly in the way that society is reacting to closures in this kind of business like steel and cement. I mean, the difference in societal reaction to, for example, a call center with 2,000 jobs being closed down vis-a-vis a industrial production site with 2,000 jobs is immense, because it has such an impact on the local community. And that's not a belittling to people who work in call centers, it's just a reflection on what this means for our welfare and our societies and our economy. So I think this is very helpful as a perspective. Thank you for that. I have the pleasure to introduce as the last speaker my colleague Keith Wersky, who has been the main author of a new report that we have been working on in Bellona Europa in Brussels, which is called Manufacturing Our Industries. It looks like this, and it is basically discussing many of those questions we heard here today, how we can avoid that in Europe, especially looking at from the European perspective, we can stop the growing risk that we have a situation where unions are going out in the street in the future and protesting climate emission. Because if we come to that point, I believe, then it's game over. So we need to make sure that that doesn't ever happen. Keith, please.
Hello, good evening everyone. I should warn you ahead of time, I'm Irish, so I might speak very quickly. So if anyone wants to put their hand up, just do that and I'll attempt to slow down. I do that at the start of every presentation, but it never really works. Okay, so I'm going to give you 4 very simple messages. And one is that industries are important, their decarbonisation is very important, and CCS is an important tool in that decarbonisation. The last part is the part that we haven't really talked about, is how do we make that last step happen, and how do we make it happen in a cost-effective way. So here I have taken Europe as an example. We can see that about 20% of emissions come from industry at the moment, and another 3% from waste disposal. So if we're going to get to a low-carbon world, we can't start picking and choosing what emissions we remain. We have to tackle emissions throughout our economy. That includes agriculture and that includes industry, and they have to deeply decarbonise, or deeply prevent CO2 from entering the atmosphere. And we don't really have a choice. If we wanted, we could shut down industry. But we're also in the mood, and we're changing our entire economy. We're building a new low-carbon society, and that requires inputs and investments. So here's an example of a wind turbine. A wind turbine is about 90% steel. I use the calculation here that the European Union plans to build 1,000 gigawatts of wind turbines in their low-carbon energy roadmap 2050. That requires inputs. That requires steel to be put in. We can't just say that we won't use steel in the future, because we actually have to build a new society. The same goes for building. If I was going to build a house now, I would love to build a passive house, a house that had solar panels on the roof and was very thermally efficient. To build that house, I would use more concrete. You'll use more concrete to build up the thermal mass of the house. So just because we're building things that are more efficient doesn't mean that we're using less resources in the future. And that means that we have to make these resources in a low CO2 way. Nitrogen fertilizers is another example. Natural gas is converted into hydrogen and is combined with nitrogen to make nitrates. This is responsible for about 1% of global CO2 emissions. This also has to be dealt with. We can't say we won't use fertilizers in the future. The fertilizers feed the vast majority of this planet. We need to decarbonize this. So it's not a conversation about cutting things away from our society, finding out how much of it we need and finding out how we can decarbonize it. So I'm a geek or a wonk or whatever you call it, so I spend all my time reading reports. And all these reports say that CCS is absolutely crucial to deeply decarbonizing industry. It pops up everywhere. It pops up from steel to cement, chemicals, incineration. It's throughout society. So if CCS is a part of the solution, why aren't we talking about more in the terms of industry? So CCS is actually remarkably simple. You have a source of CO2, you transport it, you can use ships, you can use pipelines, you can use barges, and then you store the CO2. And you can also use some of the CO2 along the way as well. If it is so simple, then how come we haven't done very much of it, especially in Europe? Well, it's because when we look at the investments, it's actually the other way around often. So even though CO2 storage looks like the last step, if I wanted to develop a CCS, an industry CCS project, you would actually have to start with the storage. This is the part that takes the most amount of time. My background is in geology. You would have to employ some geologists, they would have to go mapping, you would have to drill holes, you would have to see if this is a suitable site, and then you would have to get to a very high level of confidence that this can store CO2 on geological timescales. This can take between 5 and 10 years. And only when you know where your CO2 storage site can you really start planning your transport. And then at the end, that's when you can start looking for your resources. So the investment is kind of the opposite of the way we often think. We often look at where the CO2 source is and we say, you must capture it. But that's very difficult if the CO2 has nowhere to go. Another finding that's become very obvious recently is that having a single transport link to a single store from a single source can be quite expensive. You have it often much cheaper, just like in our normal day lives, that we share infrastructure. We have CO2 infrastructure that takes CO2 from many sources and can bring it to many different storage sites. So where are we in Europe right now? We have 2 CO2 storage projects. They're both in Norway, and one's been operating for about 20 years or so. But we haven't really done that much more. We have no very large transport systems in Europe at all. We haven't really developed that. And we have no very large capture, especially from industry sources. So we're quite far away from our ambition of having a deeply decarbonized society if we're only start getting going now. So will our current mechanism actually build a CO2 transport and storage infrastructure? I think the quick answer is no. So if we have an ETS, the emissions price that we use in Europe, the price signal comes after the investment should happen. I mentioned that the CO2 storage part, your investment has to happen before you develop your capture plant. But if the price signal comes to the capture plant too late, then that will delay action. Similarly, the price signal does not encourage planning of oversized pipelines. Would I build a pipeline or a transport link that was just the right size for my single plant, or would I oversize it so my next door neighbors can use it in the future? The ETS does not encourage me to oversize the transport link. And also, the CO2 transport infrastructure itself and the investments involved in it might be much longer than, say, the investments in my steel mill or my cement mill. I might be able to make those investments. So the end result is we won't have the amount of CO2 transport and storage that we require to deeply decarbonize. And that means less decarbonization. It will happen later, and when it does happen, it will happen at a higher cost. So when we look at actual Europe's goals, so Europe wants to increase its industry base. We want to grow to 20%, and we also want to deeply decarbonize. So I think it's easy to say there's a certain tension here. How do we increase industry while decreasing CO2 emissions? Well, at the moment, the answer is a pretty bad one. We just say that at the moment, we don't have a solution, so we'll exclude certain parts of our industrial sectors from having to pay CO2 taxes or having to meet CO2 obligations. So in Germany, it now looks like there'll be less obligations for the steel industry on ETS. In my opinion, this is bad for industry. It means that there has a lot of uncertainty about what obligations they have to meet in the future. It's bad for climate because in the interim, the CO2 continually goes in the atmosphere. And most of all, it's bad for these heavy industrial regions. They will lose competitive, they'll lose inward investment, and they won't be able to attract new low-carbon businesses. The primary way around this is that you need to look at the social good. And if the social good is in the transport and the storage of CO2, then we need to have some government involvement to help develop that network in time so it's available at the lowest possible cost for industry to use. I mentioned that sharing the network is the cheapest way that you can reduce costs in the CO2 storage. So we need planning so we can shared networks, have oversized networks. Also, if we manage to develop CCS with shared networks, that means that we can reduce the price at which the ETS actually becomes competitive. It means we need a lower CO2 price in the future to decarbonize, not a higher one. So we propose using a state-owned or state-funded, centrally planned CO2 market maker, we call them. This will tender for CO2 transport and tender for the CO2 storage. And that way we can start to build out the transport and storage network in line with the decarbonisation goals. I won't go into too much detail, but for different parts of the CO2 transport network, this is really required. If I was going to build a CO2 storage site, I would find it very difficult to invest if I wasn't assured that I would receive CO2 in the future. Similarly, on the other side, if I was to build a CO2 capture plant, it's very difficult for me to invest without any guarantee that I'll have some place to put the CO2. That's why we need some planning authority to de-link these risks and say, don't worry, we'll have a network in place and we'll grow the network at the right speed. So here's an example of the Ruhr in Germany, and this is how I would start. I would make an authority that had a certain budget. I would tender for the development of CO2 storage. I would map where my CO2 sources are, and I would start getting CO2 to the North Sea and begin storing it. And then we can start showing it works, and then you can start expanding it. This gives assurance to the people in the Ruhr area that they do have a deep decarbonised trajectory they can follow into the future. In relation to the European Union, there isn't many funding schemes available, but they're very disparate. We have to work to join them up and see if we can get them used in a way to concentrate on transport and storage development and not to be used solely on capture development. And as the main benefactors, it's important that the industrial regions, the areas that actually house these industries and areas that have this employment, take the lead and push for the development of these market makers to begin developing this network that we need. And just one final point. So these are the three projects that are hopefully going to go ahead in Norway. And I want to describe how flexible a CO2 transport network is. So we have a waste incinerator, a cement kiln, and an ammonia factory, a fertilizer factory. All of these will be deeply decarbonised by one single transport system. So CCS and ICCUS offers us huge flexibility in how we decarbonise. It doesn't matter what CO2 you put into it. You can decarbonise steel, you can decarbonise cement, you can decarbonise chemicals. But if we don't have the infrastructure at the right time, we lose all of those options. And that means we get into a difficult place where people have to say, I cannot decarbonise, therefore I cannot, we have to have a choice, do we keep your industry or do we decarbonise? So we need small, moderate investments now to begin the development of these networks so we can grow them into the future. Thank you.
If I could ask all three speakers, we're not going to touch that again. If I could ask all three speakers to please have a seat here. We're going to open the floor for questions. We have about 10 minutes time. I think it's been a nice introduction here to a little conversation with the audience as well. So I'm not going to waste your more time. Just if someone has a question or a comment, please put your hand up. Oh. Hans-Jörn wants to start, please.
I would actually like to make a comment on that issue of German steel industry and German government regarding ETS. As it was presented, I wouldn't underwrite it, but I would underwrite a certain of the conclusions that came out of that. Reason basically is, in a nutshell, the European Union's Commission's proposal is to reduce, saying there's technical progress, hence we emit less and less year by year, hence we just basically cut what you get by a certain percentage point, full stop. And the comment made was just to say, look, it doesn't work like this because our actual emissions are not going down, not because we don't want them to go down, but because we have reached a technical limit below which they can't fall. And that's the reason why we have clearly said, look, for that it makes no sense to want them to be lower if they can't be lower, so you have to put the benchmarks at a realistic scale. That's actually what's behind that headline, just in order to avoid some confusions. And therefore the general idea is exactly as it was presented. We have certain things where we are just running into physical realities. And believe me, there are two kinds of laws in this world. The laws we deal with as engineers, thermodynamic laws, mechanical laws, and those are the politicians. The problem of a thermodynamical law is you can't have 3 readings of the parliament and change that law.
All right, thanks for that. Do we have some questions or comments from the audience? Please, here in the back. Do we have a microphone, Olav?
I can just speak loudly, it's fine. A lot of the conversation here...
Sorry, could you introduce yourself and which...
Thanks for having me. My name is Holden Leslie Bull. I'm here from Yale University in the United States. A lot of the conversation is focused around removal of point sources of emission from industrial sources, from power plants, from what have you. What do you see as the role of direct air capture in carbon capture and sequestration going forward?
I think the easiest way to start by explaining this is, well, what's the concentration of CO2 in the air? So 0.04% or so. So the concentration in your flue would be about 12 to 13% in certain areas. So from an efficiency point of view, it makes much more sense to capture it when it's at a high purity state, so in industry. So I don't see why it would make sense to pollute it into the atmosphere where someone else may possibly clean it up in the future. We should catch CO2 when it's entering the atmosphere. As we said, CO2 in the atmosphere is a problem.
Further questions, please?
Just another point on the air capture. Even if you do air capture, it still doesn't get rid of the need for the transport and storage, because if you're capturing it, you still have to put it somewhere or use it somehow.
So someone else in the panel wants to comment on that? You shouldn't hog the microphone. So.
I mean, as I briefly said in my presentation, it depends on the time. I fully agree. Today, it's not the most effective way, but we might well come post 2050 to a situation when we really want to have a negative carbon balance rather than in order to achieve net zero, that these might be the things we need, but effectiveness and efficiency are things we should be looking at.
That's the next question
Well,
here.
I just wanted
please,
to add
go on.
that, yeah, of course, what I think is important is if you look at the climate challenge, you have to start where it's most economic and where it's most efficient to do it. So I'm not saying it can't happen in the future, but you should start where it pays off to do it to begin with and get the ball rolling, and then let's see what happens after that.
Please, we have the next question, I believe.
I'm Luis from the Amazon Natural Capital Institute. I was just wondering whether there are environmental risks associated to storing CO2 underground.
Well, I would just like to say that the first risk is the CO2 in the atmosphere. It's a very known risk. It's why everyone is in this hall here, because we have a risk of massive and unreversible climate change. I'm a geologist. I was trained to take oil and gas out of the ground, but now I work with CO2 storage, putting CO2 back where it came from. Many of the oil and gas that we extract has been trapped underground for tens of millions of years, and we look for the exact same geology so we can trap CO2 and we can monitor the CO2 underground. It's all about using the knowledge we have, having very detailed surveys, and making sure that we pick the right sites where the CO2 can be stored, and how we manage those risks. And we've shown throughout the world that we have stored CO2 and we can do CO2 storage. And we also come across many natural analogues where CO2 has been trapped underground for tens of million years as well by itself. So we need to be clever about how we do it, but definitely the biggest risk is having unmitigated CO2 in the atmosphere.
This is another comment here.
Well, it's important to be aware of that. You know, it's different where you store it. You have to find a good reservoir to store it in. And there's been a lot of resistance to store it on land, onshore, but offshore, where you don't see it. It's not in anybody's backyard. It's maybe easier for the public to accept. And in the North Sea, Norway, you have stored CO2 for more than 20 years. It's actually 20th anniversary for the Sleipner field. And Statoil, who operates it, was very early on started to investigate what happened with the CO2 once it's stored. So there's huge amounts of documentation that the CO2 stays there, and that is so it's safe. It's a very good technology.
Question in the back, please.
Hello, my name is Oliver Schmidt from Imperial College in London. I would wonder what your reply to the argument that development in CCS, which from my perspective is an intermediate solution, would divert attention from the development of more long-term sustainable solutions like renewable technologies, and also divert funding.
Well, I would argue that CCS is not an intermediate solution. It is a long-term solution. You can do it, and the CO2 will stay there for centuries. So it is not correct to say it's an intermediate solution. if you talk about renewables for energy production, of course you can argue that way. But the industrial emissions, which we have lots and lots of, then definitely you don't have the alternative of switching to renewables because the CO2 is created in the chemical processes. So I think it's not about either or. You need to do all of these things at the same time in order to combat climate change. So it's very risky to argue that way, I think.
Maybe I could jump in on that as well, because this is something we as an environmental NGO, of course, have been discussing a lot, both internally and with other NGOs in our movement. And I think, you know, the way to see it, and that's what Keith was talking about here, is that infrastructure is going to be needed for CO2 from a set of sectors for the foreseeable future. That doesn't mean that it's not possible to get out of that, and that we should do all we can to reduce emissions from all those sectors. But I think that most people who look at that will agree that there will be residual emissions from all those sectors. And if we focus on building the infrastructure, if we focus on preparing storage for that CO2 and building infrastructure to strategic clusters, then for at least the next investment cycle, we can avoid that we get lock-in on CO2 that we will not be able to deal with in the should we say, the time scale that we have to deal with climate change. Now, you know, then if we come to the point where we don't need CO2 for those various sectors, CCS for those various sectors anymore, then we still see from the climate models we're likely to need bio-CCS and use sustainable biomass to reduce CO2 from the atmosphere. Now, I think that if we have that perspective, we also avoid this kind of zero-sum discussions where we say either we do CCS or we do renewables or we do energy efficiency. Because we should do all those things, and then we have to deal with the CO2 that is left if we're going to deliver the Paris Agreement.
I mean, as I said, we have a toolbox, or we need to have a toolbox. If you have a hammer, it's very good to have to get a nail in the wall. You can get a screw in the wall with a nail as well. Whether it's a good idea, I'm not quite sure. If you have a nuts and bolts system, you're pretty sure that your hammer wouldn't work anymore. And that is exactly the thing, and it might well be that CCS in the terms of the global scale of 50 gigatons of greenhouse gases is not actually going to be that big hammer in your toolbox. It might be one of the fine tools you're not needing all the time, but in the case you need it, it's very unfortunate if you don't have it, but would have to resort to the hammer.
Right, we're running out of time, so I'll take one last question if there's one. That seems to be the case. Yeah, please, Tom.
My name is Tom Wildeborg. I'm here for the CO2 GNet Association, working on CO2 storage. I'm not a financial specialist nor macroeconomic specialist. How can you keep the competitiveness, let's say, of steel and cement industry with implementing CCS schemes? So, or what are the requirements to keep the industry competitive?
That's to Hans-Jørgen.
The question of competitiveness is not a question of price or cost. It's a question of price or cost difference. And this is exactly what you have to look at. And that's this so-called, often quoted level playing field. It's not about how high the playing field is, but how much are the different sides of the playing field at different levels.
You definitely need support from the governments. To begin with, the cost of emitting CO2 is not high enough, nearly high enough today. So what we're doing in Norway, and I didn't mention that in my presentation, but the Norwegian state has said that these industrial emitters don't have to take any responsibility for transportation and storage of CO2. The state will take care of that. And it's also part of this infrastructure building. And they will also support the industry for a period of time until the CO2 price comes up. So we're kind of trying to find business models where these businesses, these industries can show the world that they can do this technologically, and then we need to find new business models for the future. But definitely this has to be also supported by governments, and then the industry has to respond, and then you have a new level playing field.
Keith, any final words before we wrap up?
Just saying that having the network-led approach and the CO2 storage-led approach, if you get a shared network, that is the way of reducing the costs the most. And if you can reduce the cost most, then that will reduce the differences in this leveling playing field. So reducing the cost of decarbonisation should be our goal, because we all have to decarbonise unless we want a 4-degree world.
On that note, I would like to thank the speakers especially, but also everyone who's been here. I think this has been quite interesting. I enjoyed it a lot. I hope you have done so too. I wish everyone a splendid weekend. But before that, in a weak moment here outside, I was encouraged to tell everyone that in the Moroccan Pavilion tomorrow at 1:15 there will be an event on sustainable cities, which I would like to encourage everyone to attend. So on that note, thanks a lot, everyone, and enjoy your weekend.
Nej, jag får se det.